So we're going to apply what we've learned so far, in that we can use an equation. In this case, we're going to use for the instantaneous velocity. We will utilize what we know about limits to create an equation of the slope at any given point, so that we don't have to redo everything. In the last video, when we found the instantaneous velocity at 5 seconds, we found out that it was traveling at 160 feet per second, and of course, a negative value means that its trajectory is heading towards Earth, you could say, rather than away from Earth. So it's traveling down. In solving this, then we're not actually going to plug 5 in for t sub 0. What we're going to do is we're going to try to work this out so that we can plug in any time, 1 second, 8 seconds, 5 seconds, and get that speed. So for that given time. So let's go ahead and begin with the same steps, and we will use what we have up here. So we'll just say that f t sub 0 plus h and f of t sub 0. So for f of t sub 0, and actually I'm just going to continue using the correct variable, so at s. And the reason I say that is that here we are given the equation for the trajectory, and what we want to do then is just go ahead and solve this down for the slope at a point. So we're going to say that this is equal to, at s, t sub 0 is equal to just 500 minus 16 t squared. At s of t sub 0 plus that little bit of h, we will end up with 500 minus 16 multiplied by t sub 0 plus h squared. So when we FOIL t sub 0 plus h squared, we will end up with, and let's just walk through this carefully. So we have t sub 0 plus h multiplied by t sub 0 plus h. And I think, so as not to confuse, I'm going to drop the sub 0, and we're just going to leave this as just simply t. So we multiply this out, we end up with t squared plus 2 times th plus h squared. And that's FOILing this out, of course. So here we end up with a value of 500 minus 16 multiplied by t squared plus 2 times th plus h squared. Now we carry through our 16, negative 16, and we end up with 500 minus 16 t squared minus 32 th minus 16 h squared. And then we continue to combine like terms if we can. In this case, this is what we're left with. So let's go ahead and plug in both of these to our difference quotient that we've been using. This time, since we're going to find the velocity, the instantaneous velocity of this, we are at a point rather than between two separate points. We're saying that this is as the limit of h is approaching 0. And we're going to have s of t plus h minus s of t. So we plug this value in first, and we end up with, write this a little smaller here to fit on the screen, 500 minus 16t squared minus 32 of th minus 16 h squared. Let's put some parentheses around this, and we are subtracting. And then we have 500 minus 16t squared. And of course, all of this divided by h. So now the fun task of reducing this down. So let's go ahead and let's multiply by that -1, and then we can get rid of these parentheses. So we will end up with the limit still of h still approaching 0. And we have, and I'm going to, if it's okay, I'm going to go ahead and now I'll just move through this a little quicker here. Normally I would take the largest exponent value and reduce it down from left to right to the smallest, but this should be pretty self-explanatory. It's just algebra. So we're going to go 500, negative 500, sorry, positive 500. I can do algebra, but basic math gets me every time. So 500 minus 16 t squared minus 32 th minus 16 h squared. And we carry that through for a negative 500 plus 16 of t squared. And now we can combine like terms. So plus 500 minus 500, those are now 0. We have a negative 16t squared and a positive. So those are now 0. And this, of course, is over h. So now we can rewrite this in a simplified form. And remember, we're trying to reduce the denominator. We're trying to eliminate h in the denominator. It is approaching 0, and we cannot divide by 0. So we have negative 32 th minus 16 of h squared. That is over h. And if you can see this, right now each term does have an h. We can reduce from here, or if your algebra is a little rusty, let's go ahead and show you for the numerator. For the numerator, we're going to factor out an h. And yes, we could factor out our lead coefficients here of 32 and 16, but we don't need to. We're really just concerned with eliminating h in the denominator. Do not create more work for yourself. So negative 32 of th minus 16 h squared. And we're going to factor out that h. So we will end up with, as the limit of h still approaching 0, because we have not replaced h with 0 yet. We bring that down. And we have h multiplied by negative 32t minus 16h over h. We'll reduce this. And now we have limit of h as it is approaching 0 for negative 32t minus 16h. Now we can substitute our h as the value 0. So we don't need to bring the limit down anymore. We're just going to substitute and say negative 32t minus 16 multiplied by 0 gives us our slope equation at any point along that trajectory. That means that negative 32t, if I plug in 5 seconds, if I plug in the 5 seconds such that s at 5 is equal to, and we said our formula is negative 32t. We plug that in, and we end up with negative 160. What's great about that, not only did we find what we did in the last video, that the instantaneous velocity at that given point along the trajectory is 160 feet per second, if that was the unit measure. Not only do we know that it's a negative trajectory traveling, as you could say, towards the Earth, we can also now substitute any time along that trajectory that we want. We could put 8, we could put 0, anything that we want at this, using this formula that we have created for slope at any given point. And that makes it a lot easier. So I hope that helps, and thanks for watching.